Okay, I think we're up and live. Let's double check everything's going good. Gotta go send messages to everybody, let everybody know I'm up. There we go. All right, so today we're going to be doing the bezier grid overlay, so that way we can actually calculate the warp cells. Let's see. So oh. Okay, we are trying to catch up with some people here so we can get this going. Okay. Welcome back, everybody. Glad you could all join. So today we'll be going through the Bezier curve, the blend cycle. So the idea is that I'll be building the underlying linear grid that is then used to displace the eventual 2D grid that's for the sprite data. The tool that we got together in the last stream, you can move the joints around. There is a bug that I'm going to have to work through at some point, not necessarily a game stopper of any sort, but when the Chrome debugger is open, I get really bad slowdowns. There's some workarounds I found that explain why this might be happening, but nothing I honestly understand because there's no debug information explaining why this is broken. But thankfully today, I will not be using the debugger heavily, and nor will I be moving the points too terribly much, so I think I can kind of just work around it and close the debugger when necessary. The other interesting thing is that when I record the performance to see if there was something wrong with my code, it runs perfectly fine. So I'm not 100% sure why that's doing that. So real quick to recap a little background, I know there's people that come in and go, don't really know what I'm working on, just so everyone kind of understands what's going on here. I'm really interested in the 2D animation artwork that seems to be kind of popular these days. I find that the problem solving interesting. So there's this anime girl here. If you come in here and you pick a feature, the features can be warped with these curved Bezier displacement maps. I don't know how you call them, or warp meshes or whatever. And I thought that was interesting, was wanting to kind of reverse engineer and understand the algorithm and then maybe eventually build a tool around it. I don't know that I'll go as far to build a tool, but that's what we're working on. So today, the specific thing that we're working on is going to be dealing with the actual lines that make up this grid. So I need to make up the displacement grid, the linear grid that goes in there. And so like this has a 2x2 displacement area, and let's say that it had something like a 7x7 actual. Let's see if I can get that sized up correctly. Let's say that this particular thing had a 7x7 cell mesh in it, or internally, and so I need to generate the individual lines that make up this grid internally, mapped across the deformation transforms for the beziers. So I'll be generating these lines today. Now these will just be straight lines that then get linearly interpolated with the control points from the top to bottom for each cell in this area. And so I'm trying to figure out how that will work, what that looks like in code. And yeah, that's what we're going from there. So to start with, I have to figure out what cell I'm currently in. And so this is what some of this code, I worked on this a little earlier today. So we iterate over the number of individual grids that we have in this linear grid, right? So this is like, say, 7x7. So let's assume this is a 7x7 grid. For now, I'm doing it constant. So on the 7x7 grid, we need to figure out which cell that we're currently in. So we take our current cell, let's say that this is cell 0, 1, 2, 3, 4, 5, 6. Did I only say 7? 7, sorry. So we take the cell, so we take the x over the width, and this will give us our 0 to 1.0 on this left to right. This will tell us the index that we're on. If I take the vertex count, so I multiply that number times the vertex count minus 1, this will give us these two numbers. So this gives us a 0 or a 1 to calculate the index for this particular cell. And I do that for both the width and the height for the x and the y dimension. And then I calculate the x and y offset. Now this x and y offset happens to be in unit space that ends up being, I'm trying to remember how to express this. It ends up being like a larger, oh no, I'm sorry, this is, yeah. it calculates the amount of difference that you get here. So when I'm in this cell, when I'm in this square on the right side, my offset's going to be x of plus 0.5. My y offset will be 0. And so what I do is I calculate that offset, but then I subtract it from the blend amount, because while I might be blending 50, 3% or 7%, whatever this line might be, I'm really only blending 10% of this particular line to the right or to the top to the bottom. And so the idea here is that we want to code for, we need to know the actual blend percentage for this subsection of the grid. And so now that I've calculated that, what I'm doing here is I'm generating, iterating from left to right, top to bottom. So I'm generating all the vertical lines right now. And so the idea here is I will be, since I'm generating a list of vertical lines, I will be filling them into this, and then I will be putting them into the output of the renderer for the mesh grid. So I did a lot of this earlier today. I think I'm pretty close to the right answers for most of this little math stuff here. Let's see if we can. Am I not rendering it right now? So I have the mesh grid offloaded here, and then I have the. Yeah, it looks like everything compiled well. Okay, so I'll show you if I do a console log, I can just kind of drop the pertinent variables, and you can kind of see how this generally walks the index of the. And then we'll do, since we're doing it vertically, let's do the y offset, y blend. Oh. And so you can see all the numbers down here. What they produce is, it says, hey, you're in the y index 0, 0, 0, 0, then you're in 1, 1, 1, right? So this produces 7 vertices. It actually needs to generate 8, but the 8th vertex is literally on this line. So I think I may generate that as a special case. And you can also see how the y blend ratios walk the line segments. So it starts at 0, goes to 0.142842, and then obviously it skips over half, which is over here somewhere, and this gives us a 7% mix of this, or sorry, 7% mix of this rate of this line to this line. And the next one's like a 21 to 80, and then 35, etc. So you can see how it walks the whole length of this. It should be, the last one should be something like 3.5 plus. This part could be off because 0.3 is only 1/3 of this whole line. So, oh, that's the y, sorry, the y blend, but it doesn't matter. It's the same math both sides. But this looks like it's walking correctly, and then all of a sudden it gets to here, and it goes from 0.7 to 2.1, then 0.35. It feels like it's not quite right, like it almost halves the numbers in that quadrant, because this is 0.14 offset, 0.14 to this, but this is 7, that's 14. Okay, that's that. Okay, so it does look right, but it seems like it's not going far enough. It may be that the width here needs to be incremented. I need to do +1. That could be what's going on. And yeah, because it probably can't. Interesting. Oh, I gotta struggle. I think I just gotta struggle bus through this. So it'll be. We will go to kind of see what the output here is. So yeah, I'm iterating. It produces 7 offsets. Now this doesn't include that it would be. If I copy this, store as global variable. So temp1.y blend plus 0.5. That's 85 plus 0.14. Oh yeah, that does work out right. I think that's correct then. Okay, so now that I have the general numbers for what would be filling out these blended lines, I have to calculate the points. So here's the set of points. If you remember in the first stream with the Python code, I actually had some stuff to blend between the actual the points as they were. And so I had this. I had a piece of Python code that would render grid lines, and so I may duplicate that code. I may also just try to do it a little differently. So I created this mix vector, which is similar to the original one that was like blend vector, average vector, or something like that. But I decided to call it mix vector, and then this would be something like. In this here, we have to calculate. So we have to go from. Since we're calculating from the X down, so we're currently in a cell. So we're currently in, say, let's say we're at 0, 0. This is the line we're calculating, right? Oh yeah, that makes sense. Okay, so this is a line segment. It's a subset. We're calculating the subset here of this line, right? We're in this quadrant, so we need to calculate this line, which is going to be point at. So in the code here, what I want to do is I want to get point at, and it's going to ask for the points, and I just give it P1. So this is, say I want to get this first point that's on the, whoop, that's going to be closed. Sorry about that. My house is close to a highway. We always get the nice sounding vehicles driving by. Yeah, so I want to get point at, and this point at is going to be, takes a P1 in the control, and let's say that since I'm calculating down, I want to get P1, I name this P2, this is P3, and this is P4. So P1 and P3, and then I want to get the control point for down on P1 and up on P3. So P1, then I want P1 dot nodes, and remember it was up, down, left, right, so it's 0, 1, and I probably need to codify those in an enum somewhere. I'm probably going to hurt myself if I don't, but P2 dot nodes, this is going to be 0 for up, and then P2, and then I need to come up with a blend percentage, right? Like, so how much of this line do I want to get a point of? And so that is going to be the it's going to be the current Y blend, I believe, if I double check this. Yeah, that's the amount of that line I want to get, and so I will put the Y blend there, and so this should give me a point. What I want to do is I'm going to go ahead and inject. Why is it not liking P1? What's wrong here? Oh, it needs just vectors, that's right. So this is dot pos. So in theory, I've calculated the point, so we will just save that. But let's put a circle on that point. Let's do this. Let's do, we'll do primitive circle, color, blue, P1. I don't know why I called that P1, but that's okay. Probably copy pasta. R is equal to, we'll say 10, make these kind of large, or 5, that's right. Make them little. And we'll save that. Now I need to put them in that list here. VLines.push. And primitive circle probably needs to be imported. Why does it matter? Oh, right. It needs to be in any array because Why bother? So it should be able to load this. Let's see what's wrong. Cannot read property X of undefined, undefined, undefined. So, okay, it doesn't understand the point at function that I gave it. This should be correct. So let's double check what's going on here. And okay, so let's figure out what the cannot read undefined. So it's going to be in this thing. Oh, I turned off my source maps. That was one of the ways that could speed up this debugger issue I was running into. Wow, I can't click that. Okay. My assumption here is that the control point isn't defined for whatever I'm looking at. So let's go ahead and spit out the P1, P2. And we can probably kill the other one. And then let's see what happens with the exception. So we actually get two. We get a warp mesh vertex. P1. Oh, let's do a dot pos. I'm pretty sure it's going to be the nodes is going to be the culprit here. Yep, so these have got a position. They are the... I wonder why these are the same point both times. Oh, because it's generating the first line, then the second line. Okay, yeah, and they're in that same cell. So my guess is going to be nodes. So we'll just do nodes 1. So P1 nodes 1, P2 nodes 0. Yeah, so P2 is undefined on both of these. So let's double check that P2 is what I think it's supposed to be. So, you know, our P1, our index is going to be, the Y index is going to be 0, X is going to be 0, 0, then X plus 1. So this is going to be the point to the right. So P2 is going to be to the right. That's probably the problem. It needs to be P3. And it looks like I generated some nodes here. So yeah, we generated a few points on the line. That doesn't look like it generated enough points on the lines. That's interesting. Oh, the reason that could be... It is interesting. I'm not 100% sure why that might be. Let's not make them blue. Let's make them yellow, since nothing else is yellow. And then I will draw them on top of everything else. I think they are already. So it's generally doing what I want it to do. It's generating the line segments on this line, but it's only generating a few, and they're very compressed. I know what the problem is. The Y blend amount needs to actually be doubled because it's halved in the grid, so I need to double this. So for this specific instance, it's going to be times 2. And then I need to fix this for the general case just to verify this looks about right. So this looks about right to me. This is exactly what I would expect. Yeah. Yep. And then, so what this means is I need to multiply it by 2, and that is going to be the number of Y items that we have. So it's the Y vertex count. So it's going to be this Y blend times vertex count Y. Oh. That's awkward. I don't know why that would be. I don't think that number is it might be -1 then. Oh, it's a 3. Okay. So it would be this vertex count -1. Yeah. So this generates all the lines for the leftmost line. And it doesn't generate any lines for the x dimension at all. I wonder... We iterate over the x. I wonder what's going on there. It's almost as if it's not calculating an x. We're not doing any of the blending yet. We're just getting the points for the... Oh, right. All I'm doing is getting the nodes. Right. So all I'm doing right now in mathematically is I'm just getting these this control node here. I'm not blending the actual Bezier curve across the grid. So the way I would do that is I need to generate I'll need to blend the control nodes themselves, and then I need to linearly interpolate. I need to, once I blend the control nodes, I'm walking down this mesh. So I'm generating, let's say, a control node here, right? And I'm walking down this mesh, and I need to generate the interpolated control nodes for this line that doesn't exist, right? So that means I need to take this line, and I need to grab a point off this line at a specific y offset. So that's the first thing I want to do. In order to get that line, I have to generate it based on the control nodes as are. So that's what I currently have is I need to get point at these lines towards the y blend, which is exactly what I already did. So this is going to be, we'll say this is VP1, and we'll say VP2, and VP1 and VP2 are the left and right sides of this new line that I need to create. So I need to get these 2 points. And so this is going to be, instead of P1 and P2, it's going to be P2 and P4, I believe. P2 and P4. And we'll say this is VP, VP1, and this will be VP2. And I will refresh this. So I should see control points along both line segments now. There's we're getting this error just because that's a React thing. That's not a big deal. Doesn't break anything at the moment. So right, so now I'm getting these 2 points. Now these are obviously not what I don't want those points. I need to generate the... I need to blend the... As I go down this line, what do I need to blend in order to get the right numbers here? See, these will always follow the right paths when I define them like this. Yeah. And in order to come to, so like I need to calculate this line segment. This one's going to be, if I calculate it vertically, it's going to be this blended with that. So I guess that's how that works then. It would be... So to come up with the control point, let's see, VCP1 equals... We're going to mix the 2 vectors of P1 pos to P1.nodes, right? So we're going to mix the left side with the right side. Yeah. And this is going to be X blend And this is going to be then P3, P4 over here. So it'd be P3 dot pos, P3 nodes 0. And this would be P4 dot pos, P4 dot nodes 0. This seems right to me. So this would be the now virtual control point for the new line that goes across here. And then in order to generate, I probably need to push these. Let's see what these look like. Oh, they generated in a weird spot. This could be because they're relative. I don't remember how this... We take A minus B, basically. Okay, okay, we take this minus that to get the number. We don't... Yeah, so this ends up being a unit vector. No, it's actually not a unit vector, but it is a vector that's been moved back to the origin. So in order to get the right vector here, I need to add its offset, and its offset will be equal to so I need to calculate the top line as well in this situation, I think, because I need to get the control nodes that go across this as well. This might make more sense if I just was able to draw these lines out, but man, this is So we know we're producing the control point, and I get the VP1, so I get P1 gets created at whatever line we're currently on, and then VP2 is this one. At which point we need the control lines for that. They come from this. They don't come from... Yeah, so I need to blend this control line and that control line, or this vector. So this is the rightmost line, and I'm drawing these lines down. So in order to do that, I need to... That's the opposite side of the mesh. That's a different line altogether. Oof. So we're calculating piecemeal. We're calculating the single point that is here, and in order to do that, I have to calculate this line, and then ask what point you're at here, and that's going to be based on the blend of this control point. So this is point 0, 1, and 2. So 0 to 2, blending the control nodes to the right. So it's not the control nodes that we see here, the P1, P3 nodes. It's I need to mix in this control node to generate the next horizontal line. Well, that's messed up. That's a brain melter. Because, and I'm not sure how to express it because it keeps bothering me every time I think through this. It's a hard one to think through. Right, so we're iterating over the whole mess, and we're trying to generate each individual vertice, and so because it's not, there's no way to batch this easier. Oof. graphics programming, am I right? All right. Well, we know we've got our vertical points, and so now I just want to mix the control nodes for the left to right. Don't make any sense to mix, but we do want P1 pause, right? Because we want P1, and then we want P3, but it's not the down the down control node we want, which is the one I mixed. It's not P1 nodes 1, because that's up, down. I want the one that points off to the right, so that's left, right, so that should be 3. So this should be P1 to its control point that's pointing to the right, and that blends with point 3. I may have to just blend a whole bunch of these. Well, it's because that's actually true. I really need to know the blended control points for like for 4 different things, so it actually makes a lot of sense to not worry about just do them all, and then I can figure out which ones to use as I need them. 3, 4, and I have to figure out the ratio. So I need to have a P1.pause, P1 nodes 3, and so this is P1 nodes down, P2. Oh yeah, these are that's the wrong nodes altogether to take, because this is blending the vertical line segment, because this is the horizontal line segment with the vertical control nodes. So this is just wrong. That's definitely what's going on here. It's a horizontal line with the vertical line segment. So I need the rightmost, which is 3 here, and then I need the leftmost here, which should be 2. That's the line. That's the nodes I need to calculate. And then that's going to be offset. Is going to be P1.pause plus this. Okay, now it's mad at me. Why can I not? What does it return back? Oh, right, I do .add. And so this is going to be, and then I need the other way around. No, I need oh yeah, I need to invert the X blend on the other side of this. So if I get, so this is the P1 position. I want to get X blend % of P1 mixed with P2 for left versus right. That looks correct. But then the second control node is going to be more or less the same thing. No, it's going to be P2.pause. Oh, this blends it. This is the Y blend. This is supposed to be blended on the Y line. Oh my God, this is confusing. That's horribly confusing. Jesus. Yeah, what's happening is I need to calculate a point that's out in the middle of space, but it's based on 4 other vectors that have to be like calculated, and I'm struggling keeping track of what I do with what. This current loop is also constructing vertices going the down direction. really do want, I want to blend I want to produce horizontal lines that have these control nodes blended with these control nodes. So if I'm producing horizontal lines that blend those control nodes with those control nodes, then I need to blend P1 right with P3 right to get a right one. That's making sense. So P1, its vector for its control node, this is going to be to the right, and then this is going to be P3.pos, P3 nodes also to the right, and that's the Y blend amount there. Okay, so this feels correct. Then the second control point will be the one. So I won't need to, once I mix it with this Y blend amount, I won't need to actually mix anything this direction back up. I only need, now I need the one that is this control point. So it's going to be p2.pos.add, and then it's going to be the p2.pos, and it's going to be 3. It's going to be 2 because I need to go to the left. Up, down, left, right. So left. This is 2. And then this should be P2. So yeah, P2 position, P2 nodes 2. Then I'm going to do P4 position, P4 nodes 2 as well. And this should also be the Y blend amount. And this should be Y as well. Okay, so this should produce control points that are somewhere in the middle of our grid. This is close. It's not exact. Something's not quite right, but it is generating them off of this. If I can drag one and we kind of see how it moves, you get an idea what the error is here. Okay, it's not, let's see, it's also not moving the control node to the position. It actually needs to be added to VP1 and VP2. So this would be VP1, VP2.pos, VP1, VP2. Adding the mixed nodes. There they are. So this is the control nodes scaled for the lines as they go down the grid. So if I can't grab that node because the control node is overlapping the yellow node, so I can't grab it because of the way my. But you can see that this now warps those other control nodes correctly, blending them across the thing to make a grid of nodes. Okay, so this is now a set of control nodes that I'm capable of doing stuff with. So the idea is that VP1 with a control node crossing through VCP1, and then another control node VCP2, and then the end point is VP1. So I could do, instead of pushing these, I could do vlines.push the primitive bezier line, and we can see what that looks like rendered out. So we'll say P1 is going to be VP1, and P2 is VP2. And then we do, what was the other ones? C1 is VCP1. C2 is VCP2. And then a color. I don't know. Make it white. Make them stand out. Okay, so now this generates the lines. Now the lines are straight because the most of the deformation is in the straight line. Yeah. So now I can grab the lines, maybe grab the control nodes and warp them. Oh, it's fascinating. The top line doesn't get actually warped at all. That's weird. The top line's node should basically just be this control node. Well, it's so much smoother when I get rid of the debugger. Oh, I can't drag that point for some reason. Yeah, look, the deformations are in the opposite direction. I've got this blend. This blend is incorrect. It's not that the blend is wrong, it's that the mix vector is actually backwards. I kind of thought it might be, so I actually coded it like that so I could swap that around. Yeah, there we go. This is what I would expect to see. Oh yeah, that's great. Okay, so now that I'm generating the lines, note that I'm not generating what looks like the last line. I'm almost curious what happens if I just go +1 since I'm generating. So yeah, it can't actually get a +1 because it can't go that far because it's indexing somewhere. Let's see. I suspect I may just have to special case the last lines and draw them manually, but okay, so this is getting there. That was a bit of a struggle, not gonna lie. Mostly because a lot of mental gymnastics to think through this. But I'm liking this. This is what I would anticipate seeing. What I want to do is I want to take at some point I want to take like what I see over here in the actual art program in Live 2D, and then warp its meshes, and then kind of see if mine does something similar. I'm not going with like my goal isn't to clone Live 2D. I've started thinking that I might do my own sort of like algorithmic stuff here, just kind of just to be different and also be a little easier to code. Or might just be, who knows, I might be able to come up with a proper full linear interpolation of this bezier grid space. I don't know that I'll be able to do it, but I can struggle through and we can find out. So right now I'm generating perfect splines across these, but we need to generate the actual line segments because from what it looks like to me is that we generate a two-dimensional grid of line segments, and those are used as basically lookup tables to the actual like warping mesh space of the original art program, the Live 2D. So, and this seems like a really good way to do it because then you get the tri-mesh for your artwork, and it can be linearly sampled across this linear grid that you've generated, and it's probably less computationally intensive and things like that. So. Also, this like sharp point that where it crosses the center line here, that seems to disappear when you just generate a really low resolution subgrid. So I think that's the right way to do this. So I need to start generating the actual lines. We're there. We're getting there. So now that I've generated these control points, I can now say, hey, let's generate a point on that line. So this would be what do we call this? I don't know. Let's call this a GP for like grid point. And so I know that I have a point that's a vp1.pos, and it has got a control node of vcp1, which is an actual control point. Yeah, vp1, vcp1, and then vcp2, and then I do vp2, and the percentage here is going to be the xblend amount. x blend times warp mesh vertices count x minus y. And so if I generate a primitive circle on that point, now these need to blend. There may be more to this than that. I'm wondering. So this generates our grid of points that I can now basically generate lines through, and this is how we warp the meshes. And all right, so I need to generate the last lines, which really they're just these control lines, so this shouldn't be too hard to do. I might generalize generating these points, but these look correct. This is exactly what I would anticipate getting. I'm kind of stoked. This is looking good. And then I can get I can start getting the 2D art portions in where I can get I'll start nailing down how to actually put the artwork into here. I found some uh, copyleft anime art that wasn't absolutely abysmal. A lot of it doesn't look the greatest, but that's fine. That I'll be using as my sample art just because it'll be the easiest to use. Um, I think when I'm done with when I figure this all out, I might try to figure out how to make these into SVG transforms. That'd be really cool to take SVG like artwork and be able to make it warp and blend correctly. And there is a mechanism for doing convolutions in SVG. I don't know if this would map directly to convolutions. Now it might map to like a really large convolutional array, but again, it's kind of outside the scope of what I think I can do quickly. Um, I'm really just surprised this was that kind of that easy. Like it was a struggle, but once I got it, it was boy, it feels nice. I could play with this grid for hours, just kind of moving things around. Wonk 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 wonk. All right. So this needs to generate all of the lines for the lookup tables for this thing, and that. I have to start thinking about how to manage a shape of some sort, and maybe I can start warping that. So we could maybe define a shape on the like here in the GUI, define a shape over to the right side that then gets plotted into this linear space, depending on how I warp it, or maybe I'll make another little editor up here I can tab between. So this is wrong and gone. We don't need that. We are generating these points as an iteration from X to then Y, and this generates them in a weird order, I think. Let me see, because I want them to be, I don't know why I just didn't swap those lines. Should be the same code output. Yeah. So because I want to be able to generate them in an array, so I can look them up in a linear way. That's really straightforward. So this generates 0. Now it's generating this direction, which makes sense. I can then take the linear array and map it out differently. I could also, should I do it that way? I could just put these in an array of just let's see, it's going to be a vector2 array of array like this, and then I could say verts y like this. Yeah, that's probably a better way to do this. Just stuff it all in a lookup table. And okay, I need to generate the last line. So okay, why am I not generating the last line? What can I do to make that work? It's doing something silly here. It's saying P3. It's because, yeah, it's because I'm generating the leftmost line of the grid cell, not the rightmost line, and I'm always generating the leftmost line. So the rightmost line doesn't ever get a chance to be generated because it would overflow the, okay. So I need to somehow generalize one of these formulas here. Somehow, let's see, I need to, when I'm generating the extra line past the end of the x, so in this case, my x index is known, right? It's going to be const x index is going to be work mesh vertexes, vertex count -1. Why is it mad at me? Oh, what? Oh, right, because it's a vertex count x. And then we'll do y index, same thing, it's just going to be vertex count y, etc. And I'm just going to copy the math over, and I'll let my reduction of complexity just kind of push that itself. How much the unit vector removed from the calculate, we don't need to worry about this because they're always going to be, the blend amounts are always going to be 1.0 because we don't need to worry about blend amounts, right? Because we're at the 1.0 for the x. The y blend amount, though, will actually will matter. So the y offset will need to be calculated. So yeah, we'll have to do that one. So anything that depends on the y offset. So in this case, we're generating it'll be we'll just grab all this, and so in this case, I'm on my x index is going to be the furthest right it can be. I can't get a line that's more further right than me, so we're going to do P1 is going to be -1, and this is just going to be the x index, and this can be -1, and this can just be the x index. Yeah. And so then I can generate those points. This should actually just generate points for me right now. Oh no, it might be generating right. Yeah, it could be generating the wrong side. Right. Oh, right. There's no, we don't need to blend. Okay, so that's what this is. So BP1 and VP2 are all about blending the nodes by looking at the line segments so I can blend for control points, but I don't need to blend because I'm just using whatever control points we already have. So in that case, I just need to supply GP with... No, I still need to blend some control points, just not all control points. I don't need a... I blend left to right. I don't... No, I blend up to down. Wait a minute. Oi. I mean, this should be successful code. I don't know why this is blowing up. Right? Because this is X index, Y index. Oh. Oh. No, that's wrong. The Y index is still calculated. The X index, however, is that. Yeah. Does this fix it? Aha, that fixes it. So now... Yeah, that's generating way over on the right because yeah, it's inverted. Although that's kind of fun. Okay. So the reason it's inverted is because this is different now. I've swapped my locations of P1 and P2. They're actually... Oh no, they're actually the leftmost. So P1 is still the leftmost coordinate. And P2 is still the rightmost coordinate. Anything that has an X blend on it probably doesn't need... Right, so this is probably just always going to be 1.0. Oh. That's a weird... It's going to be vertex count minus X. Why would it do... Oh, right. I don't know why it would do that. That should just be 1.0. Oh, weird. Okay. So yeah, it generated the correct nodes for the end of the line. I wonder why that... I kind of get it, but at the same time, I'm not going to argue with it. I get the right answer. Either through brute force or skill, one or the other. Okay, I can accept this. This is interesting. Yeah, this is good enough. Okay, so that's generated that rightmost line, and now I need one piece of stanza underneath it to generate the bottommost line of code. And I probably need to stop copy pasta in all my code and somehow generalize this, but no one's paying me to do it, right? So we can do basically the same thing where I just copy all this stuff and then swap the lines out for constants and remove the things that start to, that don't have a... So it's no longer going to be, it's, same thing here. I just set these to their maxes, right? So this is just this, that. So now that we have this, the X and Y offsets, unit vector removed from the calculator blend ratios for this square. Oh no, we actually need to, we actually need to do, the last line actually needs to iterate over X where we hold Y constant. Interesting. That's what's missing. I mean, effectively, that's kind of what this is. It's a loop at the very last. It actually makes more sense logically for me to do it this way. So that's what this is. This is... Yes. Height, then x. And then here, we do have to calculate the x offset, x index on this one. And then y will always just be 1.0 here. And that should generate something, and probably a little broken looking, but we'll take it. Oh, nope, it's generating nothing. And so that's because I'm not grabbing the right vertices. So I need to get, let's see, x index. That's fine. This needs to be -1. -1, and this is just y index. That's the first step. Okay, now it's doing the same thing the other one did where it oversampled and it's all inverted. So that is because it over calculates this blend amount down here. That can't be that blend. It has to be the other. It has to be the y blend. So this just needs to be, I think all these need to be 1.0s, which means I can probably simplify all of these quite a lot. I don't need the blend, but let's see if it works. Oh, what did I break here? Oh, right, add. Well, haha, okay. Who says you need to, know math in order to do math, right? You just fake it till you make it. That's my theory. All right, so this is now generating the grid points on top of. It's not generating this last dot. Oh God, there's an extra special case where. Can I just do +1 here? Will that work, or will it blow up? No, it'll blow up because I need to do. Oh, that's evil. There's an oof. I know exactly what point that is. That is just going to be V lines. I keep pushing these V lines. I need to push the verts. All right, so verts y equals empty array, and then I just say verts x is equal to this, and we'll no longer push them into V lines. Why is it mad at me? Choose mission. Oh, right. Yx equals that. And then so this one, verts, and that is going to be x index is this guy, not vertex count. It's going to be width -1. Or no, it actually will be right on width because I need to generate 8 points to get 7 cells. That's right. Oh, someone else just jumped into stream. I noticed the number went up, so welcome. Thanks for hanging out. We're doing math, vector math, and I'm faking it, and it'll be glorious. That's just how this works. I have faith in my inability to do math, but to think through it enough that it'll work or it'll break, one or the other. Oh, this down here. So then this is verts. This is going to be height x equals GP. And the very last thing it needs to generate is going to be verts width, or height width, and that's going to be warp mesh vertexes. It's going to be vertexes, warp mesh vertexes, vertexes dot vertex count dot x, minus 1. This is y minus 1, I mean. That's x minus 1 dot pos. Now, I can, let's just create this dots or whatever. I don't know why I call it v-lines, but that's okay. It'll just be v-lines will be verts dot map v primitive circle v what? Oh right, because it's gonna be a row, and it's gonna be row dot map. Oh right. I have to flatten it. I'll just push everything into it. Verts dot for each row dot for each vert. Points. Ugh, I really hate how I have to specify that it's an any array every time I want to do it. And a semicolon, and that's not enough. There's something else missing, another parenthesis. Oh. Is it broken? And it's broken! Can I set property 0 undefined? So, oh, right, I gotta, oh. I cannot type. I don't know why I cannot type, but, you know, it's a thing. Oh. Why would it not allow me to assign that? Did I get the wrong idea on what the error message is? I did. I have to set vert's height to equal empty array above this, because that's where the bug is at. Yeah, now we got verts. We got yellow dots everywhere. I do need to verify that the number of dots is correct. It should be 64, so because it should be like 8 by 8 dots. I will double check that with, you know, the best type of debug ever, console log. And like 3 people log out of chat right then and there. I'm sorry, okay? I'm a terrible person. Terrible person. Hey, verts.length times verts 0 length. That should be 64. I got 64. Look at that. Perfect. So now I have a linear grid of vertexes that can be then used to move a mesh of another linear array of vertexes. Oof. Okay. Oh man, we're gonna get somewhere. Man, this feels good. I'm gonna move this piece of art like over. So I'm gonna change the piece of code where this is just statically being created at the moment. I think it's up here. Yeah, it is. We'll put that at like 100 by 100. No, let's put it a little further. Let's put it like 20 by 20. And in the app, I got that weird random line that's still being drawn. Like, I don't care about that random line unless you guys are attached to it. Do you like the red line in the middle of the screen? Because I sure as hell don't. So I'm going to go ahead and just get rid of it. We don't need that. I don't even need to draw it anymore, which means I can get rid of this P1, P2. I could also maybe work on this thing. I was doing this idea earlier where I could maybe move, I could scroll around a little bit on the screen. Because this actually doesn't leave me enough room, does it? Let's do 100 by 100. I don't need to tuck it up so tight. It can be, yeah. That way I can move the control nodes, and I just got a little room, flexible room on this horrible nightmare of a code that I've written. So what I need to do, what I want to do, what I need to do, and what I want to do are probably two different things. I'm gonna generate just a two-dimensional like set of triangles, right, or some nodes or something, right? So what I was thinking I could do is I could just try to like, see, this is like the vertex mesh that I want to copy out of one of these. So if I go and edit on the atlas for this character, where is that at? So that's like the lower portion of the mouth. I want to be able to, I need to generate those. I need to be able to edit vertices like this. I need to be able to create this array. I don't know how the UI would look for that. So what I was thinking was just being a, oh wow, you can split vert. Okay, that's a feature I'm not gonna support in my program. Only the worst for my end users. That's my theory. The that's a nice feature. Damn it! Now I feel like I have to build something that has to do that, because then you have to be able to. Oh, that's gonna be fun. See, this is where I'm thinking like using SVG is almost a mistake, because I don't really get like, hey, how close is the mouse to a line? I get mouse over events. In order to get like close to a line, you have to generate like a fake line in the background that like picks up on events. But anything that's transparent in SVG, you don't get events for, right? So it's like, yeah, I could do that, but so I think what you do is you set the alpha to something like ridiculously, like to 0, so that it's transparent, but it still exists. Okay. I would like to just be able to copy all these vertexes over to my program without struggle, and I'm not sure how to do that. I don't have any easy way to just do that I know of. That would be super useful. Well, I don't know how to. I don't know what I'm doing here. So I guess. Um, I guess I'll just do it the kind of the hard way. So here's what I'm thinking. I'll just copy this over to Inkscape somewhere, and just pick a spot. And what I'll do is I'll just put all these verts down as little circles, and it'll be close enough. Like I'll just build me a little circle there, and probably make it a little smaller so it's not ridiculous. And the idea is I'll just copy and I'll put these down, and then I'll just copy all these out, and I'll figure out how to offset all these verts and come up with the draw list. Probably, oh, how's the triangle mesh mathed out? Yeah, I don't know. I'm not worried about it. I'll just do the manual steps and get it done. If I think too hard on the problem, I'll end up just getting myself into a situation where I don't get anything done on it. Sometimes hard work's the easiest way to persevere. Think too much on a problem, you won't ever solve it. Okay, so this will just give me the rudimentary little database. I'll just slap this here. So now I get a bunch of SVG data, right? And this is obviously not what I want. Like, that's way off of like anything useful. So I'm going to just kind of Swiss Army knife this through a Python script. I'll cut out all the junk that I don't care about. What I care about are these individual circles. I don't really care about the actual name for the circle. All I care about are the CX and CYs. So the kind of like my usually kind of quick and dirty way to do something like this is I will just open up Python and I'll just paste it into a little string buffer, which I totally messed up already. Foo is equal to this big old blob of text, and then I'll start doing things like I'll split it. So I'll just do f is equal to foo.split on \n, and so you can see now f is just a whole bunch of lines, and I want f to be equal to a.trim for a in f, and then strip, and then f will now be all the lines with no carriage returns. And then what I'll look for is a for a in f if not a dot starts with, is this all caps? I can't remember. If it's camel cased, like if it starts with style, we don't want it. Okay. Oh, not if not. Is it lowercase? Starts with. Oh, that's not a variable. That's a string. So now I got rid of any of the style stanzas. Cool. Let's filter out the circle. That's all gone. We don't need the thing that says ID. ID is not important. We want anonymous points. The next thing is R, because we don't need radius. All right, so this is now just a whole bunch of arrays of x and y's, and also if not a equals to. So I got rid of the empty one as well. And so there we go. Now I just parse this simple list of x, y's, and so I can do that by a dot split on an equal sign and take the rightmost value. So there's all the numbers. These are now all strings, but we can convert them to numbers by just doing something a little evil. So now they're all numbers. See, you didn't have to write a parse loop or anything. That's brilliant. And since now they're all numbers, I can do this for, let's see, I in range, length of f over 2, print f of I x colon we'll do that. X colon f of I, let's see, times 2, comma y colon f I times 2 plus 1. Did I do that wrong? Float object cannot be interpreted as integer. What? Length of f over 2, range. Is that what's going on? Does it think that there's a float involved? Is it because of this? Oh, right, because, okay, it's because I'm in Python 3. I'm dumb. I think Python 3 defaults to floating pointy-ish stuff. I could be wrong, but I think that's what the issue is. Oh, I can't do that. Derp. I can do that, though. Yeah, look at that. So now I just got a simple XY object array of a bunch of points. We go back to our app. I need to have some sort of like, guess I don't need these things. I probably actually will end up using them. So I'm going to need some sort of mesh tooling here. So the mesh right now, the mesh vertices are in sort of like, this is all like a really bad debuggable state. It's just kind of slapdash together to kind of see where this is all taking me. It's gonna need a heavy refactor. Like it's gonna need a really bad refactor. So I'm just kind of messing around with stuff. This is gonna be, we'll call this art mesh. And it's just an array of XYs. Oh, I didn't put any commas after any of this. That's all right. I know how to put commas in. It looks like it copied them all relative to where I was the center of that blob of any of them anyway. These are the art mesh verts. So now I have to come up with a way of determining lines, but I don't know how that. I don't have an easy solution for that because I just don't know how to turn a whole. Is there like an algorithm for turning like a whole like a bunch of points efficiently into triangles? That'd be interesting. Calculate a triangular mesh from a random list of points. Can we do it? It looks like you sort of can. Adjacency list representation of the triangulation. I mean, it probably ain't going to be the prettiest looking triangulation mesh, but it don't need to be pretty. It just needs work. This is all Mathematica stuff. So I'm pretty sure there is a, say, Looney triangulation on NPM. Oh, and arbitrary dimensions yet. That's the best. In the forecast? I don't know what that is. Okay. Let's look at what their code is. It's probably relatively simple. Do they have examples? They do have examples. 2D example. In HTML? No yet, no less. Not sure how this applies to what I'm trying to do. I guess that this might be something a little different. I noticed that and when I was looking at that piece of code, it said something about Voronoi, and I just realized like it kind of makes sense because if you took the Voronoi distance from each of these points to each other, you could sort of wrap them in that could be a way to wrap them in such a way that becomes triangulated to nearest neighbors and whatnot. That could be interesting. Okay, no big deal. Since these are such a small list, I think I can just probably, I mean, we're only talking like what, 30 lines? No, it's probably a little more than that. That's 5, 9, 18, that's about 20, 30, it's 50, 60 lines. Yeah, it'd probably be easier just to sort of go through it. I need to generate something that can draw this art mesh. Okay, that's important. And then I need to normalize it so that the art mesh. No, it doesn't even. It needs to be in pixel space, not in unit space. So then this is probably fine because it's really not that big compared to our current warp mesh. Our warp mesh is quite large to wrap this one, but I'll keep it large just so that I can use the UI on it readily. Okay, so then and this would just be a simple, this would be an array of start, 0, end 1, like that. And we need some kind of thing to draw. So this is mesh vertices. That's that thing. Let's do an art mesh. It'll be real simple. All it'll do is it'll take these verts, and then it'll take lines, and the vert color tomato. There you go. There's a person that watches that may not be here tonight, but he always uses tomato in his examples, and that's a little homage to that guy. Okay, then we'll do line color. I don't know, spaghetti. Can I do that? Oh, it's a good. It says CSS color names. What do we got? What's the list of HTML color names? Sorry. Oh, I got so many of them. There's great ones. Oh, coral. There we go. That's a one to use. Coral. All right. So then I need to create this art mesh thing. Art mesh function. Art mesh. Art mesh props. Wow. Type. Oh, man, I'm not doing any of this stuff correctly. And my types will be verts, lines, vert color, line color. Vector 2 array. No, it is, well, okay, my current art mesh is not technically a vector 2 array, but I'll just convert it before I send it over. And this will just be a type. I really just need to make this line just an array of numbers, so it's not like it's just this. I'll make it more complicated than necessary. And so yeah, this is just going to be an array, number, array, and the vert color is just a string, and the line color is the same string. Done, done, and done. Oh, got something mad at me over here. Oh, right, because I didn't put any actual. So this needs to be mapped. I think when I create these with when I have these X, Y's on them, but I could just do this. It's going to be art mesh and then dot map v new vector 2 v.x v.y. Done, done, and done. So this should be art mesh verts that I can pass into here, and this is art mesh lines that I can pass into there. And this is art mesh function. Art mesh needs to return something. Okay, we're getting there. So now I need to go over all the lines and all of the points, and I think I'll use some. Dark gray for the line color. Oh no, we got tomato for the verts, and okay, got it. We'll do that first. So for, let's see, props dot verts dot for each, or dot map. Yeah, we'll do that. Dot map v primitive circle. It's going to be, this is going to be a vert, so it's just going to be whatever, I call it P1. I don't know why, I still don't know why I call it P1, but that's okay. Color equals props, props dot vert color, primitive circle. Do we not have a primitive circle? Oh, R equals, well, 10 seems to be our magic number these days. That's actually quite big for this art mesh. Let's make it 5. Okay, so this should be, if I drop verts down in here, I should be verts. I should see something. Let's go find my code. Yeah, there we go. It's rotated oddly. Okay, that's interesting. I wonder if I either swapped the X and Y by mistake, or if the actual, I wonder if the like, I think that the XY axes are flipped. That's one thing to remember, right? So as I go up, so this is negative, negative, negative. Where's my actual? So this is where I'm supposed to be drawing. I think this is 0, 0. Yeah, it is. And then it goes negative, or it goes positive up, negative down, left, right. So it's regular Cartesian, not inverted computer. But the rotation has me confused. I don't know why I would have rotated that, but it doesn't really need to look, it doesn't need to be perfect because I just need it to, for something to test with. So I'm just going to swap the X and Y's, and that should be enough. Yeah, looks good to me. Like, it don't need to be perfect. Also, it does need to have a bounding box around it. That is going to be the interesting portion. How do I do? It will at some point, and when I start actually doing like properly editing this, it'll need a bounding box. What I think I'll do for now is I'll just make sure that my warp mesh can cover all the vertices that are in the original 2D map, the art. Let's get the mesh lines on the screen now. Verts, and we'll do lines equals props dot lines to map primitive line p1 is equal to, and so this is going to be a line, and it's going to be from props dot verts L0, and p2 will be props dot verts L1. Don't think there's a line. I don't have a line weight. It's just defaulted to 2. There are no lines right now, so I can't draw anything. Like I think I only have 1 line defined. We're still getting a lot of these errors. That's fine for now. I don't worry about it. So 0 to 1 should have been a line at the top of this, somewhere in the the top of the area. Huh. This looks actually accurate to what's on the screen over here, so I guess it's close enough. Okay, so I need to get, lines are, the triangulation lines aren't really that important, but I kind of just want to get them in. Oh, I'm not even rendering them. That would help. Yeah, there we go. There we go. Okay, so 0, 1. These should define discrete triangles too, I would expect, but yeah, these need to be triangles, not lines. So this is an art mesh triangle, tries or something like that, because that's what it'll be defined as on the back end. The downside is that I have no way of determining common edge, like no easy way. So I'll end up generating a lot more. Yeah, it'll be a lot more than I want on the screen. So maybe for now, I don't need it to be anything other than lines. So how about I just use it as lines? I'll pretend like I don't know that that's what's going on. I'll pretend that I'm super sophisticated, and I already did it as, I wrote the algorithm to find common edges, 2 to 3, then 3 to 4, then 4 to 5. So that's probably like, yeah, see, that just draws around that. And then we'll do 5 to 6, 7, 8. 8 to 9, 9, 10, 10, 11, 11 to 12, 12 to 13, 14. Oh, wait, skip one? What on earth was that? 7, 5, 6, 7, oh, 6 to 7. Sixteen, 16, 17, 18, 18. See if that looks crazy. That looks fine. That looks absolutely, positively okay. 18, 18 to 19. 20, 21, 22, 23, 24, 25. This is my favorite thing in the world to do, is just data entry. That's what all programming really is. It's just typing a whole bunch of data and hoping that it works. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Don't have many more of those. 26 to 27, and 27, and then 27 to 28. There you go. So now we have to start copying and getting the other ones going. So let's do 0 to, I think, 16. I think 0 to 16. That could be way off base, but oh, it ain't bad actually. 18. Look at that. 0 to 18. 1 to 17. Oh, why is it doing that? Okay, I think that's the pattern for the top row. 1 to 17. So 2 to 16, 3 to 15, 4, and we got commas. 4 to 14, 5 to 13, 6 to 12. 7 to 11. Then we can do 7 to 10, I think. Yeah. And then we'll do 10 to 8. Ugh, keep doing that. Perfect. So now I need to do 0 to 17. Yeah, and then 1 to 17, and then 2 to 16. Because it'd be 2 to 15. Alright, hold on. Yeah, that was 0 to 17. Then this would be 1 to 16. Then this would be 2 to 15. 3 to 14. 4 to 13. Five to 12, 6 to 11, something like that. Look at that perfect little triangular mesh up there. Okay. It's unfortunate that it's not defined as actual proper triangles, because that would actually go a long way to making this function with Babylon.js in the next session. I might even have time to get like the camera stuff sorted done before tomorrow, like the next session, but I think it's fine for now. So I'm not entirely sure. I can't remember the exact indexes where the next rows start on. So let's just pick a couple numbers and see what happens. 18 to 20. That was spot on. That could have been better. Although I probably want more like 19 to... no, it's 17. 17 to 19. That's probably what I want. There you go. I'll take 17 and 19, and then I'll take... from there, I'll take 17 to 20. And then 16, 20. Yeah, that looks good. So this should be 15 to 21. And the next one down would be 14 to 22, 13 to 23, 12 to 24. That's generating terrible meshes. I wonder what the meshes look like over here. They look pretty terrible too. No, they look okay. Oh, wow, that actually, I'm making the somewhat same choices that was made on the original mesh. Oh, I wasn't even paying attention to that. That actually worked out well. Right, so if this one, this was the 16 to 20 was that one. That's the vertical line. If I also go 16 to 21, does that produce the cross line? It does, but I want 15 to 20, I think. It doesn't. I don't know why I'm being so specific about this. It doesn't matter. I think that's what I would want next. It don't matter. I'm going to just take it and move on. It's getting a lot to. It's a lot of stuff to type. It'll wear you out quick. We're gonna create a new we're gonna throw this in another file. Art mesh data. Should have done that in the beginning. Oh, I meant to say export, not const. Yeah, I think I'm kind of done waffling on this stuff. It was kind of fun to set up the verts, but I didn't realize I was going to get myself stuck into it so deep. So let me get a couple more on there just to kind of get the lines around. Like I want this line to that line. I don't know what vert number that is. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I want 9 to go to 25, I think. 9 to 25. 24. Okay, 9 to 24. Then that's 25, 6, 7, 8. So 28. 28 to whatever that one was. That's 18, it's like 19-ish. 19-ish. 19 on the dot. And so that's 28. Then so that would be like 18. No, 20. Yeah. Maybe 27 to 21. 26 to 22. 25 to 23. And 23 to 12. No. 10? Yeah, that looks meshy enough. It's pretty meshy. Okay. Whew. So one thing I don't really understand, so imagine that we have this mesh here. I don't know how its unit space is defined when we go back to here. There's this red line here. This is the, you can scale it. Oh, yeah, that's what's going on. You can scale it. And then I'm assuming, however, this maps in the scaled area is what it generates when it does the deformation warping stuff. So as I move this around, it's going to be scaled. I don't know what happens if I move it outside of the warp deformer. Like, what happens then? Oh no. Ah. Uh. Shoot me. Just shoot me now. So all of the stuff I had been writing code for does not warp outside of the actual grid area. It doesn't have any provisions for understanding how that would work. It has no ability to calculate negative offsets. So I start to wonder if they've got a linear map for this, that these individual lines here are just some kind of reference, but I could probably not. They're probably doing some kind of a really truly linear system because they can calculate negatives. But the thing I don't understand is, like, in order to calculate this space, you need control nodes. So this space has to get really weird somehow, like at some point. Yeah, it's like it's averaging an. Oh, that's so odd. That is very odd. How does it calculate control nodes for that space? Oh, look at how extreme the of a situation it creates when it gets out there. I mean, they could just be repeating this control node because it shifts quite linear, like it skews, so it could be that control node that it's just duplicating. So anything left of this line is just this line and this line's control node just infinitely scaled out that direction. That's an interesting conundrum. My warping system does not even consider that as a possibility. I don't know enough of the use cases of this to see that that would ever be a thing someone would try to use. But again, just because I haven't seen it doesn't mean it isn't something people want or or are habituated to being able to. I could do that in the other app, so not being able to do it in your app makes this a terrible app. That kind of thing. So I could be way off kilter in my mechanism for estimating the whole grid warping system. You know, it's fine. I'm gonna keep, like I said, I'll keep programming it till I either break it or I get something that works. I do need to make the art mesh. It needs an offset, so that's gonna be new vector 2, and I will say like 200 by 0 or 100 or something like that, so that I can push this thing away. Offset colon vector 2. So it moved it a little bit, so I gotta move it quite a bit, like 700, I guess. Like this. That's a little better. Now it's a little kind of out of the way. I will need to come up with a unit space or something for this. Like, the way my warping system works is you need to have some kind of outer boundary box for it. Which, I guess, no, that's fine. So if I get an outer boundary box for it, I could just calculate the min-max bounding box, and then that would just get mapped from here. So all these verts will get mapped into whatever linear space this grid is here. Oh, I just realized something. If this this tool supported moving things way outside of its kind of comfort zone, how was I doing that? I just scaled it out of there. How do I drag it? Is there a button to move this out? Is there a button to drag things? What am I doing wrong here? I can just, I'm sure this is the right way to move things around. Just inchworm. But yeah, if it's out here in this extreme area, so that warp deformer affects it. It's like it's weird how much it the warping would affect. Oh, interesting. It doesn't affect it at all. Whereas, oh man. Yeah, so the scale moves it around, but the warping does not. But if I brought it back into the space, oh, there's no warping that's affecting it now. No, it warps. Interesting. So if it's outside of the top left corner, so this is maybe doing exactly what I thought it would be doing. It's just taking this last thing, and if it's out this way, it just maps it to this node and doesn't do any interpolation. This tells me that there's probably a more linear system of interpolating this than I thought. I'm probably a little off, but that's okay. I don't mind. I'm off in more ways than one anyway, so. All right, let's revert this poor girl's face. Oh man. Okay. Okay. I'm trying to think of how I want to go about mapping that into that grid space. I keep wanting to normalize these vertices. Like I kind of know what I think I want to do, and I almost feel like generating this grid was just not important. It wasn't really anything. It's not going to ever really be something I even use because I originally thought it was going to be a lookup table to this grid. But now that I know the generalized form of how to generate one of these points, based off of a unit, like I can generate these points based on the unit, like vector square of this grid. That means that I can project any unit point onto this grid. Well, I don't need a lookup table for that. Then I can just generate it. And so what I mean by that is in my controls, let me get a something I can modify in the controls. So I'm using Blueprint.js for the UI. And let's see. I want to throw a slider in. So let's get a slider, and I'll make the slider something I can modify. So I get it. Pick one. Let's look at the source code and grab one of these sliders. So I have this thing called controls.tsx, and I got a control line, so I just put another control line here. Control line. Slap in a slider. we'll say min and max. The max is 0 or 10. We'll go in increments of 0.1. I like that. Label step size 10 on change. We'll say x. So this is props.options.x. Options is defined in app types options. So we'll say x is a number. And we'll say y is a number. And so now I need to put on change. Oh, that's interesting. I think it's just a value is what I get back. So like this. Oh, I can probably just say that directly. And then I want a function x value props. So then I want to just say options const options equals props.options options.x, gosh dang it, equals value. It's not a very scalable way of doing that, but I'll take it. Set I just need to pass in a function, and the value is going to be this dot props dot x options dot x props. Don't know this. I don't know what vertical is all about. Probably just needs to be false. So save that. Okay. This needs to be x0, y0. All right, so I got a little slider over here that isn't working because I don't have the set. No, set options should have worked. On change, set options, options. That should have worked. This is probably wrong. Const or console.log value. It is exactly what I would expect it to be, and it's just not one to change because it hates me. Oh, what am I doing? Options, set options, and in my controls, and then so what I'm gonna do is I'm gonna it's not running right now. Oh, there it goes. So what I want to do is I want to use this to control this a point that gets rendered onto this warp grid area, so I can kind of see what it's doing, and then I can kind of come up with a generalized formula for that, because that's what I need to figure out, is to get a generalized formula for the warp area. Seen some people jump in. Thanks for joining. It's nice to have you around. Kind of what I'm doing is trying to understand how the warping mechanism works for this Live 2D tool. And I've been kind of playing with this for about 3 or 4 days. I got a few few episodes I pushed out. But yeah, this is it's interesting. Just kind of curious how it works. That's all. It's just the math nerd sniped me. And so I have a Bezier deformation grid tool that I kind of come up with. This is all in React using SVG as the actual drawing surface. So I do draw, I'm drawing smooth Beziers and stuff like that. Now I'm trying to come up with a linear equation, or like a linear set of like a, I guess, algorithm, or just tool or whatever, to translate this area, this mesh, into a warped area over here. And I am pretty close. I feel like I'm not that far from having at least a solution. Maybe not the best solution, but at least a solution. Um, I think what I should do. This is not. I don't know why that isn't wiring up. That should just work. I do just have a set state for in the app for these options, right? Options, and it's just XYZ controls. This is X equals value. I'm getting a value in. Oh, I've been dumb. I did right. So now I should be able to drag this thing around, and yeah, I'm going to divide it by 10 when I give it to the actual tool. I'll make that toolbar a little wider. I think it's not the nicest. It needs to be like double that width. Is that in here? No, it is not. Oh, that's right. It's in the left-right app CSS. 400 pixels. Yeah, it's getting a little better. It might be do 600. Yeah, because it's going to need a lot of room. There's going to need to be a tree graph over here as well at some point. But and then on my controls, this control line, do I have a controls.cs? I do not. Let's do this needs like a padding 5px. This is probably good enough. A little more. Let's do 15. Yeah, that'd be good enough for now. So I can bring it out far left, right. So we can. That's one slider, and now I need to get the other slider down here. We will do set y value. What I'm going to do is just do set value. We'll just do const set value equals key value like this. Props options key equals value, set options, options. And then we will do this. Set value X, set value Y. So I should be able to get, oh, I have them linked to, yeah. Bingo. So yeah, so okay, now I want to make this point chase around that warped space that I have here. That'll be fun. Let's see how I can figure that one out. If I do right now, the only place that actually has the mesh available is in this mesh vertices, which is like, it's just like a really horrible way to do this. I really need the mesh to be managed at a higher level or up, but for the moment I think what I'm going to do is just drill the props into here, since all the math for doing most of this is in here as well. So the mesh grid is here, and this is where I need to probably do that. I know I could calculate it in here, but all the other math is in there. So I will drill, I'm just going to props drill it, and then I think in about a week I'll have to take apart all these like sort of experiments and sandboxes and glue them together in an appropriate mechanism and think about how the data needs to be managed a lot better than it currently is. This is going to be const point. We'll call this the I don't know, cursor. New vector 2, and this is going to be options. Oh. Dot x. Oh. Dot x options dot y. And then we'll just say cursor. Then this needs cursor. And that just passes on to my mesh grid, which will be cursor, mesh grid will take a cursor, which is vector 2. All right, we're there. So effectively, this is going to be this math here, these XY indices. So I need to calculate what cell we're in. So this is going to be for the cursor. I know this is like a terribly written piece of code, but it'll get there eventually. So I need to put cursor in here. And cursor.y. Cursor actually needs to be divided by 10 because it's not equals cursor dot divide by new vector 2 10 10 because it's in a different space. So now that I have a unit vector for the cursor, I can take the cursor xy over the width. I can get the current index that it's in. Once I know the index that it is in, I can calculate how much the unit vector removed to calculate the blend ratio. So this is getting the blend ratios. And I can get the xy blend amount. I actually probably only need to I just probably need to copy this whole mess. This is, the blend amounts would just be the cursor. Yeah, it should just be this cursor XY minus the offsets. And then now that I have that, that's the last, I just need to do all this stuff to get a point. Const cursor point equals GP. Well, I don't need to do anything there. I just need to do that. So it compiled. Okay, so I need to render this GP point somewhere on this grid mesh. So if I do primitive circle, P1, GP, R equals, we'll say make it big, and we'll make it color equals blue. Oh man. Okay, so that's, yeah, look at that. So now I can just kind of, I get a linear ramp of any, whoa, wait, what just happened there? I don't know what that is. Okay. Okay, that's not what I expected at all. Oh, that's trippy as shit. What is going on there? So it kind of works, right? And then if I move this down, it's still working. What the hell is it doing? It should be following this other line right here. That's trippy. It follows the first line just fine, but it's somehow like, my people need me. What is that all about? Oh yeah, it's like it can go way past the. And maybe this is. Oh, that's trippy. Okay. If I let's think about this. So what's going on here? So if I'm dividing it by 10, so it should be clamped to 10.0. I calculate what index group we're currently in. I probably need to do something like, okay, we're in this mesh grid. Can I maybe throw, there's a SVG text I can throw up on the screen somewhere, I think. We're currently in a SVG context when rendering everything, so yeah, just do like something like this. So I can maybe cheat a little, and we'll do a const debug equals like this, and then some text points. This will be $sign. What is this going to be? We'll say X offset. I know that's going to be calculated correctly. It really has to be calculated correctly. I can't imagine it wouldn't be. But just for the sake of argument, this will be X colon, this will be Y colon. Oh, I probably can't. Yeah, I have to include the debug in the render. Derp. And we will put debug at the bottom. Hey, cool. We got some text on the screen that's not legible at all. This needs to be like 65. I don't know. Probably not that far. 55. Okay, so X and Y offset 0. It should have gotten in. See, it says 0 still. That's not what I would anticipate it to say. The X offset will be, so what's the X index? X index and Y index. Okay, that's, oh, maybe refresh it? No. Why are those both 0? That shouldn't be a thing. Oh, okay. So my x coordinate is not. I know what's going on here. This needs to be multiplied. This is already a normalized x coordinate. I need to figure out the index, and it needs to be this thing. Oops. Oops. Times that. That's what's going on. Oh, Crashy McCrashles. Cannot read property pos of unknown. That's fine. Let me back off calculating everything. Let's go back to. Oh. First of all, that is not. We'll do cursor pause down here. This just needs to be. Okay, so this would be. We still need the math.floor when calculating this. That's the first issue. Yeah, 0, 1, 2, 0, 1, 2. Got it. So then the x offset should be 20 to, so it's 20. So 75, 95. Yeah, that's correct. 0.5. Yep, that's doing the right thing there. The only thing it won't work for is the extremity, so it won't do the far right. So if I get to the index of like what 1 or 2, a 2, I think on these, it'll freak out, won't know what to do. But I have I can generalize that as well, I think. So then P2 and then so I should be able to generate cursor pause now from this code. I can't, if I go all the way up, it'll explode. Yeah, that's what I expected. So then let's do the debug. Let's get this down here. Uh-oh, what's going on? Oh, that needs to be debug cursor pause. Okay, so I can move it anywhere in the grid except for 1.0. I can only go up to 0.9999999, but never 1.0. So now if I warp my mesh around this, if I grab this node here, and I grab a control node and flex it a wee bit, I should be able to just jump around that curve, and it curves down. Now if I go down a little bit, I can also curve around through the rest of the mesh. This gives me a very linear space 1.0 to 1.0 style mapping. Okay, that's working. That's kind of what I would hope to see. And this is still like a very linear space down here where, there's no warping effect happening at all. And then it can curve through this space just fine. That's sort of weird. I like it. Okay. So I have the ability to map a unit vector space into this vector space, into this warpy mess over here, right? So this is what I want to do with these tri-meshes for a texture. And then I can get this Bezier warping grid over it, and I can mimic what's happening over here. So we're getting there. We're getting there. And eventually I'll have like keyframe animation and some other stuff I'll add to it as I go along. So it's likely that this grid that I generated may not have ever been necessary. That's disappointing, but okay, you know, at the same time. So I need to do a function called function calc point. And I'll send in warp mesh vertices and then a point vector 2 and a return of vector 2. Now this will be really wasteful on calculation, I would imagine, just because it's not going to be... This is why I kind of thought maybe this is what was being done. But because of the amount of like just live editing and moving around you can do on these, I don't think that really does this grid stuff. That it really doesn't need it. It might need it because it might not be fast enough when we actually start animating a lot more. You know, it might be the issue. Like, it just might need a lot more math. But because this is now in this linear space calculation here, I might be able to write a pixel shader that does a lot of this too. That would be like the ideal solution, I guess. It's just shader at everything. I would send in the warp mesh vertices and the control points as a uniform, and I would send all of the... Oh, I wouldn't want to do that, would I? I wouldn't want to send in the... Oh, yeah, that would be interesting because I'd have to run the texture mapper itself. I'd have to do all of the linear texture mapping in the triangles in the shader in itself. That might be more than I'm willing to chew off. That's a bit heavy. Well, we'll get to that when I need to. This could also be a vertex shader, but I'm not actually that great on vertex shaders. I don't know enough about them to understand how they work. But I suspect that actually would work quite well, just having a vertex shader that does the warping. Okay, so what I need to do is I want to be able to go in a negative space here. So I need to be able to pick a different set of 4 vertices depending on where the XY coordinates are at. So if down here I do a whole bunch of this stuff where I'm calculating like extraneous stuff, like extra lines, and I'm doing different control node choices, but it's the same math. So I would say if say x index is greater than warp mesh vertices dot vertex count dot x or equal to. So if we've blown over the x index, we don't obviously want to get x index plus 1. We want to just make all right. 2 p3 p4. Does that define all of them as? No, it does not. Thank you for nothing. All right, so in the one case where I'm going to go blow the x index out of the water, I obviously just want to go back an x index and then just use the current index. No, I want all these to be... I really want to go back 1. Actually, I want to go back 2 and then subtract 1 from this, right? Because this is 2 minus 1. And calc point. Oh, it's not what that is. That's a oh, come on. You're not an any. Your work, it's not an any. Ugh. So this is warp mesh vertex. And then we're going to calc point down here. It's called cursor pause or something. Yeah. Is not happy with that. Oh, right, because I didn't get the warp mesh vertices. U vector. We're getting some yelling at us. Okay, this is the debug stuff. I just killed that. Why is it mad here? Because P1 never gets assigned. So this should be the same, except for that when we get the x coordinate into an extreme position, it'll make a different choice here, and hopefully not blow up everything else. Right, so it should keep going, and then it blows up, which I kind of expected it might do. Right? That can't be right. That's got to be... What did I use down here? Oh, I did actually just use... Okay, that's interesting. I didn't use the constants, I used the variable. That's kind of almost wrong. Why is it blowing up? What did I do wrong? What did I do to hurt you? Well, I'm going to stare at this for a second, I'll tell you that. Okay, so it's... Maybe I was supposed to just minus 2, minus 1? Because that makes more sense in my head. Okay, it's blowing up. I don't know how to calculate that one out. What if I just clamped the XY indexes to something that was reasonable? X index equals... Oh, I know what was happening. It needs to be this. That's what the problem was. So the reason I was doing the conditionals is I had to pick 4 different coordinates when it's at the extreme edges. Okay, that's kind of what I would expect. Something derpy to happen. At least it blew over to the... Okay. So what happened here was that because it chose a different x index, but this... the x offset was, let's see, x offset equals 0. Oh, because it's all constants. I don't think that'll fix it. The x offset should be 1. Yeah, it's making weird choices. Let me think this one through. What did I do when this one, when x was, right? Because I'm going x0 to width, less than width. Calculating that. In this case, I think that the I think X offset is not important. X blend is what gets modified. It's 1.1, 1.0. Oh, ooh. Blew up again. That's not fair. Right. Yeah. Okay. What? Why does 0.5 work? Oh, because the X blend. Well, that's rather confusing. Oh, it's because, okay, it's not that 0.5 worked. What it is down here I actually multiply it by yeah, I bring it back into a different vector space. Okay, so that's what I'm doing. I'm multiplying it, I'm scaling it out differently further on. So this isn't 0.5, this is warp mesh vertices vertex count dot x minus 1 divided by this is going to be it needs to be half of, it's not half, it's 1 over this. That's what it is. That's why I can't think of it in my head here. Yeah. So now, okay, cool. So I can go all the way up to 1.0 and clamps just fine. And it still should follow the warp path just fine. And look at that. Look at that, just fouls in there. And we get now let's get the Y coordinate involved in this. So it still moves properly in the other two sectors of this warp path. I see a couple more people jumped in. Thanks for joining. If you have any questions, feel free to ask. I'm more than happy to talk to you about what I'm doing. And yeah, there's also some other episodes, some sessions I've been working through. So I feel like tonight might be a little longer than the others, just because I'm kind of really getting to the edge of where I want to. I mean, I'm kind of at a natural stopping point. I want to, if I got the rest of this vector stuff solved, it's a bit of a natural stopping point. But I kind of want to do more. I kind of want to know what happens if I go beyond my coordinate space there. So let's go to the control, because it clamps it now, and it kind of sets things. So my max should be like, say, 12. My min could be, we'll leave it at 0 for now. So yeah, it just clamps it at that far side, so it doesn't amplify it any. Which, you know, I may want to get it to where it just sort of extrudes this side of this mesh off into infinity, just because it might be a useful effect. I don't know, but I'm not going to worry about it. It works good in clamped space, and I'm okay with that. That's all I really expected to build anyway. So let's do this one now, so that it can go all the way up without exploding. That was somewhere around here. It's in the mesh grid. All right, so then if y index, it's basically the same math. If y index is greater than y minus 1, then the y blend will be 1 over that y minus 1, y index, y minus 2. So now I can go all the way to the extreme corner. And I can also navigate around the warped space all the way back up. And I like it. Well, since I can now basically calculate uniform vertices, I can calculate uniform like warped positions from one grid to the next. I should be able to start warping that other mesh. I'm kind of annoyed at how the structure of the code is, since it's a dirty sandbox with all kinds of just junk piled up in it now. That it's probably time I do a refactor. Although I wouldn't do the refactor on stream. I don't want to torture anybody with that. But let's see. All right, so let me do that. Let me pass some stuff down from the app. So in the app we have the mesh vertices. In mesh vertices we have U-state warp mesh vertices. I want to pull those out, and I'm going to go ahead and put them all the way back up into app. This will be, I'll do a quick and dirty refactor, nothing super crazy. So that means that mesh vertices needs a mesh and a set mesh vertices. This is going to be this is probably the wrong name for this tool now. That's fine. I'm not going to go through a full refactor on you guys. Type mesh vertices props equals, and I need it. It's called mesh, and that's going to be my warp mesh vertices, and then I need the set mesh, which will be x colon warp mesh vertices void. Mesh set mesh. All right, so now that I've refactored the mesh state to the app level, I will also pull out the mesh grid from here, and that should still compile and build and do all the goodies. I should be able to still modify it. Let's see. Yeah, we just don't have the now I'm not drawing that cursor anymore because I don't have it in that location. And the mesh grid really isn't that important to me as it once was, but I do want to draw it, I think. So I will put it down here. So it's going to be underneath the draggable, or I want it to be at the bottom of the Z index, and I want that cursor. Yeah. Oh, is mesh grid not import? Oh, did I? Is there a conflicting property cursor? Oh, right, because I need to refactor the cursor out of this thing. And so I need to put this needs to be somewhere, but I'm going to just export it from here for now. And like all of this math that's in here is literally now encapsulated into this one function, so I eventually can pull all that stuff out too. So bunch of copy pasta, but that's good, that's fine. Then I grab the primitive circle, get the v points, they'll do their thing, and go back to app. So this cleans it up enough that I can start pushing the need to change that props cursor. Yep. So let's go back to app. I'll draw the cursor on top of calc point was inside of, we'll drop the art mesh data. I don't need draggable and drag handler or circle. I don't need this loaded anymore. And mesh grid, let's see. All right, so I can't find calc point, which I exported it from mesh grid. So let's go warp mesh vertices. Let's see. That's just gonna be mesh. And it should still be the same thing as it was before. Yeah, we still got the same. All right, and then the points drawn, and we get the warpage. Okay, cool. So I need to scale. I'm just going to scale this into unit space. So it'll be stretched, just kind of skewed and whatnot for this warp grid. But let's do that. Let's scale that. So that is our art mesh, and I want to take the art mesh. Where's oh, it's a constant, right? It's just a variable. So I have art mesh right here. That's art mesh verts, and I want to normalize it. I want to do that before I don't need to run it. Const unit art mesh verts or something like that. I need to figure out the min max of the space. I wonder if there's an easy way to do that. So I'm using Babylon.js for the vector library because I'm also going to eventually use Babylon.js for the all the texturing and tooling and stuff like that that I need to do. I'm just going to create polygons for everything and just throw them through Babylon.js. Okay. I need to get the min max. Okay, it needs to be a little more than that. All right, so function normalize art mesh. Min equals see const or no let min equal vector to some arbitrarily large number. Let max equal the same thing but negative. For let's say art mesh verts dot for each. I thought you could set it in place or update. Is it update or just set? Is it set? Oh, geez. I thought there was a set for vector 2 in Babylon.js. We have add in place. Let's see, in place. Add in place, multiply in place, divide in place, scale in place, subtract in place. All right, whatever. I don't care. Just create a new vector. Then min. I probably just want to do it this way. I'll say min x. Min y. Max x. Max x, max y. If this vertex is less than the min x, then obviously min x must be that vertex x. Vx, v dot x. If v dot x is greater than max x, x equals v dot x. I probably could just do math.max. I don't know why I was, whatever. It's fine. It's fine. Code doesn't need to be perfect every time you write it, does it? Is that really that important? Max y. That's not, this is, wait a minute. Okay, this is min y, max y, y. Why? All right, so now that I've determined the min max for all vertices, let's normalize them by mapping them. So let's say const result equals art mesh verts dot map v. To normalize them, I'm going to take the v. I'm going to say v dot subtract new vector 2 of min x min y, and then I'm going to say the dim, so const size will be like new vector 2 max x max y. We just say max, yeah, and then do min. Yeah, min x, min y, and then I'm going to take the, I'm going to take max and I'm going to subtract it from subtract min from max, so I can get that into normalized space. So then I take all these vectors, I subtract the min from them, and then divide by max, and that should just be returned. And so now I should have normalized art mesh if I do this. Let's see what that looks like. Let's see what the output is. Undefined. Oh, I didn't return anything. That would have been helpful. All right, we got something. And these numbers look more or less what I would expect normalized vectors to look like. You know, none of them are over 1.0. Yeah, good enough. Okay, so now the fun comes. I want to take the art mesh, and for every point in the art mesh, I want to calculate a new mesh points. So const meshy is normalized art mesh. Let's do const normalized equals this thing. I'm getting so many random global variables in this mess of coding here. All right, so if I take the normalized points and I do a map on them, I want to then take that vertex or that point, and I'm going to say, hey, let's calculate what that point would look like against our interesting little mesh P. Well, that's simple. Okay, and so now that I've got meshy, now this is going to be, these are going to be the real points in XY space. So all I have to do now is just take the art mesh and literally just draw art mesh right over the top of art mesh offset. I don't think it needs an offset. I think this would just be vector 2 0 0, because I think these will be absolute position coordinates. We'll put verts equals meshy, and then lines would be equal to the same lines, so art mesh lines. And we'll do the colors. I think I have some HTML color lists. I got a dark gray for the lines. We'll say dark gray, and then I'll pick something like I don't know. What else we got here? Indigo. There you go. Indigo for the vert. Indigo. dark gray. Verts. Oh, look at that. Oh man. All I gotta do now is start getting that yeah. Okay, so yep, I can warp this thing. Alright, the debug window is slowing me down again. So I can warp it around. It kind of acts a little differently than what maybe I would expect, but it's a usable tool. I think that's more important than anything. It's just, you know, being a tool that you can use. But yeah, if I start drawing my filled polygons with this, uh-oh, can't click this point for some reason. What is interrupting my mouse cursor there? I mean, the UI can obviously stand to have some fixes. Boy, there's something in front of my mouse cursor there. I can't touch that point at all. Oh yeah, I can't. There's a bunch of things I can't click on. I'm not sure what's going on there. Why can't I click that? What is going on? Am I getting... Oh, it could be... It shouldn't be this key thing. That's just all these things being drawn without really any... Like this point's being drawn on top of everything. Is it something that I didn't draw? No, I drew it. Oh. I mean, I could put this art mesh underneath the mesh vertices here. Oh yeah, now I'm able to drag the center line. So maybe that's what it was. It just couldn't get the click event. Wow, now I really just want to get the I want to figure out how to get the Babylon JS 3D context on the background, but we're at the end of my 3 hours I normally run. If you're new to the channel, if you're hanging out, you're checking this out in post, or if you're watching it live right now, I say thanks for joining at this natural stopping point. I want to get to the refactor of cleaning up some of like the junk code that I've been throwing in here just to kind of figure things out. I'm happy with what this is right now. I'm happy where it's at, and so I want to. It sounds like it's a terrible plan. Just told me I should put the texture on there, you coward. You know, it is only 10:40. You know, what's another 3 hours? You know, I don't have a 3D context right now, and to draw that with matched coordinate space might be the death of me if I tried doing that tonight. It could go real easy to match the 3D coordinate space to the 2D coordinate space, or it could go really, really, really terrible. Yeah, that's actually. I was thinking about doing the latter. Terrible Plan and I play Minecraft together, and he's telling me I should get out of this and play on the server that I've been hosting for a while. Yeah, I don't know. Man. You got me tempted. Uh, what I think I have to do is I have to build the scene for the Babylon JS. It's only been like 3 or 4 days that I really haven't had a chance to play on the server. You'll be fine. But yeah, the okay. So if I get a Babylon JS scene in here and I get an orthographic projection camera, then I have to determine like how do I make it one-to-one projection for pixel for pixel so I can have this SVG grid overlaying the other you know the 3D context so that I can draw these things in the same sort of space. That will be the challenge. And even then, we're still talking about I have to generate custom meshes. I have to generate the triangle mesh, the triangle. Oh yeah, I still don't have triangles. That's probably gonna take me 30 minutes an hour just to type out the triangles. Yeah, no, it's a good stopping point. This is good. I'm happy with what I got, and I'll end the stream here. And I'm glad that everyone could join that joined, and hopefully we'll keep going with this. Thanks for hanging out.